So this is f is equal to and 4x divided by x squared plus 9. Okay, this is an interesting function. So first, the domain is obviously the real line. Okay, the domain of f is R, because this is never going to be equal to 0, and this is an odd function, right? F of minus x is minus 4x x squared plus 9, which is minus f of x. Okay, so this is odd, which is okay. We just need to plot half of the function. Now it is going to be continuous. It's going to be differentiable everywhere. There's only one 0 at 0, right? If 0 is 0, what happens with the derivative? The derivative is 4x squared plus 36 minus, and then we have 4x times 2x, so 8x squared, right? Divided by x squared plus 9 squared. So this is 36 minus 4x squared divided by x squared plus 9 squared, or in other words, this is 4 times 9 minus x squared. Okay, 4 times 9 minus x squared plus 9 squared. So here we have that the zeros of the derivative are going to be plus and minus 3, right? And so we have that the function is going to be, let's see, going to be positive between 0 and, sorry, f prime is positive between, or let's see, in this interval, in minus 3, and it's going to be negative everywhere else, okay? In minus infinity, minus 3, union 3, infinity, right? So we have, what's it, a minimum at minus 3, right? And then maximum at 3, right? Now what happens with the concavity? We can compute the second derivative, and then this is equal to, let's see, using this formula, minus 8x squared times x squared plus 9 squared, and then we have minus 36 minus 4x squared times 2 x squared plus 9, right? All of this divided by x squared plus 9 to the 4th power. Okay. Now we can get rid of some powers of x squared plus 9, so we have minus x squared times x squared plus 9 minus 36 minus 4x squared times 2, right? If I'm correct. Oh yes, and this is the derivative of this 2x, okay, times 2x. And this is 8x, not 8x squared. 8x. Okay, and divided by x squared plus 9 cubed, right? If you operate on this, what you have is 8x cubed minus 226, sorry, 16x divided by x squared plus 9 cubed. And 216 is a multiple of 8, so this is just 8x that multiplies x squared minus 27 and divided by x squared plus 9 cubed. So the changes of concavity are going to be at 0, and then at the square root of 27, which is 3, the square root of 3, right? So this is going to be, let's say, this is going to be positive whenever x is positive and x is greater than 3 square root of 3, right? So positive if x is greater than 3 square root of 3, and because of symmetry reasons, if f is smaller than minus 3, and it's going to be negative. Let's say, no, wait a minute. So this is going to be positive here. It's going to, so convex, right? The function is going to be convex. It's going to be also, yeah, and it's going to be negative if x is between 0 and 3 square root of 2. Okay, this is concave, right? and we don't really need to care about the negative side because it's going to be minus that, right? We don't have any vertical asymptotes, right? Because this is again 4x divided by x squared plus 9. This is never going to be 0. And then we have the limit when x goes to infinity on both sides. We have it's equal to 0, right? The limit when x goes to plus minus infinity of f, it's going to be 0. So we have a horizontal asymptote. Okay, so no inclined asymptote, horizontal asymptote in this case. Okay, so let's plot this first part and copy it for the negative side, right? So we have again a maximum at 3 we had set, right? The function at 3 is going to be 12 divided by 9, 18. So 12 divided by 19 is going to be let's see, so it's 12 divided by 18. We divide by 6. This is 2/3, right? So something here, 2/3. Function is 0 at 0. We have multiple here, so it's going to be, remember, concave here, and oops, okay, concave here, and then at some point it's 3 times the square root of 3. So let's say it's here, then it becomes convex, right? So this is the inflection point, something like this. And then the same way, because the function is odd, you just need to copy it in the negative side, right? So something like this. Okay, this is f of x somehow. Okay, and that's it.